The ICS-64 is a modern redesign of your favorite 8-bit computer from the 80s. This new version is based on several different original motherboard designs, taking the best of each version and adding some modern techniques to give you that classic retro look with the reliability that surpasses the original. This FCC Part 15 compliant design minimizes the classic's EMI and RFI noise by providing a better circuit layout, filled ground and power planes, and of course components themselves these days are much better quality than what was available nearly 40 years ago. The ICS-64 will be available in two different versions. First is a version that has all the SMT parts already soldered and ready for you to install your through-hole parts. The second version will be a bare raw circuit board. The ICS-64 uses the same bill of materials as the original KU and 250407 assembly motherboards. You can use these or a variety of other original motherboards for obtaining the custom chip, quote-unquote, donor parts that are required to complete the ICS-64. The required donor parts are the two 6526 CIAs, the 6510 CPU, the PLA, the SID, basic and character ROMs, and any discrete logic chips and connectors that you don't want to purchase new. The ICS-64 gives you a lot of features never imagined for the original. Let's flip the board over and go over all of those features. The ICS-64 features a 32 MHz microcontroller, cleverly hidden on the backside of the board. This tiny processor controls the kernel ROM selection and other advanced features. Now, just by using the restore key, you can reset the computer or switch kernel ROMs. No external switches or mods are required. Simply hold the restore key down for 1 to 3 seconds and release the key. The computer will then reset. Holding the restore key longer than 3 seconds will reset the computer and also select the next kernel in the EEPROM bank. The restore key hold duration is programmable, and there are visual indicators letting you know what operation will occur. You can select up to 8 different kernel ROMs using a 27C512 flash ROM, but a variety of EEPROM types can be used. The ICS-64 will be available with licensed Commodore 64 ROMs from Klonto, and an option to use a licensed Jiffy DOS ROM as well. CBMSTUFF will even include the original licensed Magnum Load ROM offered by Utilities Unlimited. One other thing, that restore key circuitry has been greatly improved. No more having to beat on the unstop restore combo in order to break out of your basic program. You can see there's information printed on the circuit board that shows you the various ROM banks and settings. If you are building this as a raw board, you can enable any bank of the ROM you like using the convenient solder pads. These pads are large enough to solder wires to for switches if you want to go old school and have some external switches. With the SMT version, you would leave the kernel ROM solder pads all open. The ICS-64 was designed to allow you to use either the stock Commodore 64 basic and character ROMs or optionally use 27C64 EEPROMs. Instructions on how to set the solder jumpers are printed on the circuit board for the basic ROM as well as the character ROM. The ICS-64 was also designed to allow a variety of original custom chips. Both NTSC and PAL VIC-2 chips are supported, and you can even use either the 6567 or 8562 by selecting the primary voltage with a solder pad. So a donor VIC-2 chip can come from either a standard C64 breadband or a C64C. Even the PAL version's interlace mode can optionally be changed. So let's look at a few features that make the ICS-64 really easy to build. Notice that this image shows 2 different joystick port connectors. That is because several different versions can actually be used. You can use the original C64 joystick port connector removed from a donor board, complete with a screw hole for mounting the screws. You can also use a slim DB9 connector with soldered tangs. And lastly, you can use a full-size DB9 connector also with soldered tangs. All of these connectors provide the proper spacing for the case. So, back in the day, one of the biggest fears was damaging your computer by plugging in your joystick after having walked across that shag-carpeted room. That big bolt of electricity almost certainly guaranteed that your favorite game was no longer going to do anything more than tease you with its presence. Trips to the local repair center or waiting on mail order parts are a real drag when you're trying to outdo your buddy's high score. To prevent this heartache, the ICS-64 comes with TVS protection diodes located right at the joystick ports. This offers the absolute best protection for your CIA chips. Let's flip the board over and go through some of the other features. The ICS-64S, or S means standard version, uses the video circuitry found in the original design, albeit with some changes. First, the clock crystal can be one of two different types, either the traditional lay-down crystal or a vertical mount crystal. Why a vertical mount? Well, if you put a socket under that vertical mount crystal, you then have the option of easily switching between NTSC and PAL by just changing the crystal, the VIC chip, and the NTSC jumper position. No soldering or desoldering is required. There is also a version of the ICS-64 called the ICS-64E, E meaning enhanced. The E version uses the 8701 clock chip to replace all the video circuitry. The C64C used the 8701. This version also has the ability to switch between NTSC and PAL by just changing the crystal, the VIC chip, and changing the NTSC and PAL jumper. It's a lot less circuitry to build, but the 8701 chip costs a lot more than the standard video circuitry. In keeping with the theme of trying to be as compatible as possible with original components, you can also either use a 6581 or 8250 SID chip by using a 12 volt or a 9 volt regulator while you're doing the build. The ICS-64 already has the proper capacitor necessary to boost the volume for digital samples when using the 8250 SID chip. Speaking of the SID, there's a great option for those that use Messiah, Prophet 64, and other music creators and players. Both joystick port pots are available internally, complete with power and ground. This makes adding remote pots a super easy plug-in installation. Unless you purchase just the bare board, the ICS-64 will come with a very upgraded RF modulator replacement. Luma, chroma, and composite signals are amplified, filtered, and balanced, resulting in an amazing video output. Seeing is believing. Using a stereo SID chip has always been a hassle of having to run an extra set of wires out of the computer. There has been really no way to deal with this until now. Next to the RF modulator circuitry is a pad labeled L, where you can solder the second SID chip's output, so it becomes the left channel. The right channel is the original SID. By using a simple 3-pin header to a 3.5mm or similar stereo jack, you can provide a convenient means of getting your stereo SID sound out of your computer. Of course, if you like RCA jacks bolted to your case, this makes it easy to take the case apart by just unplugging that 3-pin header. Moving on, you can see there's an internal IEC port. This 6-pin header uses the same configuration that some SD2 IEC devices use, which is compatible with the IEC portion of a C64 Reloaded board's connector labeled CN4B. Located between the kernel and the basic ROM is another 6-pin header. This is the expansion header for the ICS-64's microcontroller. One set of pins is for the LED output and the other is labeled as aux. That can be an auxiliary input. This connector is also used for flashing new firmware updates. The LED output is for driving a WS2812 RGB LED or a string of LEDs. By default, several LEDs in a strip are driven as a status indicator for such things as the state of the restore key, for reset and kernel selection, XROM, IRQ, current ROM, and other things that can be displayed on the LED strip. It's also possible to do some crazy things, like drive a 256 LED panel to display scrolling text. Because people are using more and more peripherals, one of the shortcomings of the original motherboard design was addressed and fixed. The user port power is located a long ways away from the power input. There is a simple yet effective LC circuit placed on the user port's 5-volt output. This makes a big difference with devices that draw power in surges, such as EEPROM programmers, relay stations, Wi-Fi modems, and others. This will handle over 1 amp of current. Below the LED and aux port is the I/O port. This is a dedicated 4-pin port that you can plug an OLED screen into. This screen gives you details about your motherboard, including the 5-volt supply voltage from the power supply, the state of the IRQ and XROM lines, the restore key state, current ROM bank selected, the uptime of the computer, and a whole lot more. This is also the gateway to the menu system where all settings can be easily programmed, again using just the restore key. The ICS64 has ample spacing between components to make it easy for assembly. The color-coded diagrams, like what you see here, provide clear documentation for what part goes where. The ICS64 uses a power supply circuit with ample space for a large heatsink on a TO220 type 5-volt regulator. And there's also an option to use a DC to DC switching regulator from Recom, CUI, and others. The switching regulator is less than $10 and highly recommended because it completely eliminates the heat that a regulator normally causes, and a DC to DC regulator makes the 5-volt output very stable and quiet. Instead of using a bridge rectifier like the original motherboard design, the ICS64 uses separate diodes. This allows for using larger current versions in case you want to pull a lot of current through the user port or drive a large RGB LED panel. The Retro Repair Station is the ultimate tool for retro enthusiasts and hobbyists. It's an IC tester, reader, and flasher. It's a 2-channel voltmeter. It's a 2-channel oscilloscope. It's a frequency analyzer. It's a frequency generator and PWM driver for servos, steppers, and relays. It's a color composite video generator supporting various resolutions and test patterns. It can be completely portable, requiring no external power, and a whole lot more. The Retro Repair Station can test virtually any type of 3.3 volt and 5 volt IC, 7400 and 4000 series TTL chips, CPUs like the 6502, 6510, Z80, 8086, 8088, 8051, and many others. It uses an easy-to-use open script language that lets you build your own test parameters. The Retro Repair Station can dump any size ROM up to 40 pens. The file can be stored locally within the 3 megabytes of onboard storage, sent to a server, or stored on an external SD card. The Wi-Fi interface makes loading and saving of files a breeze, and firmware updates require no moving of files, just issue the command. The 4-pin expansion bus provides a serial port, which can turn the Retro Repair Station into a simple terminal, and when used in conjunction with a Bluetooth keyboard, you have a quick way to debug serial-based consoles, powered either through a standard USB Mini-B cable or optionally a single-cell LiPo for a complete portable setup. There's an easy-to-use menu system shown through a 65K color 1.8-inch TFT display. Take the mystery out of your arcade machine, home computer, or microcontroller project. Paying homage to the original Super cartridge that I created in 1990 for Utilities Unlimited, the new Supercart 2 is a cartridge we all wish we had back in the day. The Supercart 2 is a standard size cartridge for the Commodore 64 or 128. It is a complete low-level diagnostic cartridge with the ability to bypass the CPU and diagnose issues with the custom chips such as the VIC, the CIAs, SID, PLA, and even the CPU itself, as well as the RAM and the ROMs. You can load program files instantly into memory from a server, internal storage, or from an SD card. You can freeze and capture the entire 64K memory map and resume from a saved state. There is GeoRAM emulation and REU emulation. Options up to 16 megabytes will be available. There's an option to use an external kernel, complete with working RAM under the image. There is CBMSTUFF.COM's popular Y modem built in, but with a twist. SwiftLink emulation is available, but there is also direct parallel access to the modem possible, giving you up to 1 megabaud in transfer speeds. With internet access, wireless firmware updates are available. Some planned future features are a CPU accelerator and memory and I/O sniffer with breakpoint options. A small OLED display and push buttons make it easy to set up and use the Supercart 2. The XIA is a drop-in replacement for popular interface chips used in various Commodore computers, as well as Apple II, Apple Macintosh, BBC Micro, Atari, and many stand-up arcade machines. The XIA is a cycle-exact emulator, able to emulate a variety of chips, up to 2 MHz. These chips include the 6520 PIA, 6522 VIA, 6523 TPI, the 6525 TPI, the 6526 CIA, the 6530 Myatt and Riot, the 6531 RIOC, the 6532 Riot, 6821 PIA, 8520 CIA, and the 8521 CIA. A single push button and RGB LED allows you to program the type of chip to be emulated.